All right, well, I hope everybody is doing all right today. With the little time we have left, we're going to keep going with those identities, these that we have here. We haven't introduced all of these yet, and that's okay. We'll probably finish that up tomorrow, and then on Tuesday, we'll just keep going. Don't forget, in 1 week, what is happening? Okay, you got your exam. Okay, so the exam will cover these identities here, okay, all of those that we've been studying and those that we will look at, and the other portion of it is actually going to look really similar to what you just did. You'll be evaluating inverse trig expressions for me. Okay, so it's 11 questions, 10 are multiple choice, and you can always do what? You can always use your notes on your tests and your quizzes. Okay, so if you have any questions, later on, let me know. Well, let's do a quick little review. We've had all these identities. We've got my 6 reciprocal. Okay, the ratio quotient, tangent equals sine over cosine, cotangent equals cosine over sine, and then the 3 Pythagoreans. Those were extremely important to us. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. So we're starting to get to the point where we see these expressions and we want to simplify them as much as possible using these rules. Okay, so let me give you a couple of these. Let's say if I asked you to simplify secant of theta times cosine of theta. Okay. So neither of them are squared, so I'm probably not thinking a Pythagorean identity, but which identity that we were just talking about would you think be useful to me? I'm thinking probably maybe the first category. The reciprocal, okay? Like for example, what is the reciprocal of secant? Okay, so it is 1 over cosine, right? I'm going to leave cosine as is. One of the better strategies is just to rewrite everything in terms of sine or cosine if possible. And you'll notice what happens here. Cosines cancel, so that's just 1. Okay. Now, some of these may take some additional steps in order to get to the answer you need. Some of them are going to be just that easy. Okay, they're not going to have a whole lot to them. And remember, there's always more than one way to simplify these. I took the reciprocal of secant. Could I take the reciprocal of cosine? Yeah. Okay. Which would be 1 over what? Secant. Multiplied by secant. See, those are still going to cancel. You're still going to get the 1. Okay. So as long as you are using, those rules, you should be just fine. Okay. What about this one? If I were to give you 1 plus tangent squared of theta. That's it. The answer is just secant squared of theta. Remember, we have a Pythagorean identity that tells me exactly this. We know that 1 plus tangent squared of theta equals secant squared of theta. So I just replaced that binomial with secant squared. That's my answer. Okay. What about... Let me give you another one here. Let's try, how about this one? Tangent squared of x times cosecant squared of x. Tangent squared of x times cosecant squared. Okay. All right, what do you guys think? How could we simplify this? And I will tell you, this will reduce to a single trig identity. Yeah, Angel, what do you think? Okay, it's not just cosine. No, we're close though. Let's see, what's a really good strategy that I mentioned? Okay, I could rewrite everything in terms of what? Sine and cosine, right? Now remember, we know, for example, that tangent of x by the quotient identity or ratio, depending on what you want to call it. Which one was he? Was he the sine over cosine or cosine over sine? Okay, so tangent is sine over cosine, right? Okay. So tangent squared would simply be sine squared over cosine squared. See, we're just going to take the square along with it. Tangent is still sine over cosine. We also have a reciprocal identity. Okay. We know that cosecant of x is 1 over what? Sine of x. Okay, they are reciprocals. So what is cosecant squared? 1 over sine squared. Okay. Now this was a really good way to do it. What do you notice? Yeah, the sine squareds cancel. So 1 over cosine squared. Now 1 over cosine is what? Secant. Okay, because that's the reciprocal identity. So what's 1 over cosine squared? Secant squared. There you go. Okay. Anybody have any questions? Anybody not seeing how I'm doing this? Okay. Would you like to try another one, or you think you're ready to move on just with the notes? Can you do the notes? All right. Good, 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 good. Let's see where we got to. We were using the quotient identity. We used the idea of decomposing. We spent some time yesterday talking about factoring. Okay. The trinomials and the binomials. Okay. So let's look at this one right here. Simplify. Okay. Secant of x plus 1 times secant of x minus 1 over sine squared. Okay. All right, now I'll tell you this one also simplifies to just a single trig function. There won't be any fraction left. So variety of ways you could do this. Some people might go ahead and rewrite the secants as 1 over cosine, but then you'll want to combine that with 1. It's going to get you there, but you may be giving yourself extra work because you're going to need a common denominator. You'll have to simplify fractions. What I would do probably if I were to see something like this, okay, there you go. Okay, say that louder, Nathan. There you go, because you recognize those groups as what? Well, now if I multiply them, I get difference of squares, but these groups right now, they start with a C. Conjugates. Okay. You remember conjugates? Those groups, the A plus B, A minus B form, okay, where the first terms are the same, the second terms are opposite. So if I multiply those, I am going to get a difference of squares. So why don't we go ahead and do that? Now, how do I multiply binomials? What's that acronym we like to use? FOIL. FOIL stands for first, outside, inside, last. So I'm going to use arcs to go ahead and tell me which ones I'm multiplying. So what's secant of x times secant of x? Okay, so now secant squared or secant x squared? Secant squared. Okay, we'll never square the variable. It's like when you're dealing with a logarithm, anything you perform on the logarithm happens to the log, not what we plug into it, not the variable. Okay. Now let's go outside. What is secant times -1? Okay, so negative secant of x. Now if those are my outside, inside is 1 times secant. What's that? Okay, just secant of x. And the last, so I'm going to multiply 1 times -1. Okay, so that's just -1 over sine squared. Okay. So is everybody okay with what I did? Okay. Now, when you multiply conjugates, something's going to happen for your outside and your inside terms. What is that? There you go. They're opposites. One positive, one negative, so they're gone. So I've got secant squared of x minus 1 over sine squared of x. Okay. Now remember I said this is going to simplify. It's no longer going to be a fraction. It's just going to be a single trig function. Okay. Would you like me to give you about a minute or two to try it out on your own, see if we can get it to the answer? Okay. Is there anybody who would be stuck where to go from here? Does anybody want a hint? Now remember, is there always more than one way to do it? Always, there's going to be a ton of ways. But if I were to continue this problem, I would look at the numerator. Okay. What do you think that PYTH stands for? Okay, so I would probably use a Pythagorean identity there and see what happens. Okay, so let me give you a little bit of time. Try that out. Okay, so let me see if I can catch up to you. You may not be done, and that's okay. What Pythagorean identity was I referring to? The second one. Okay, so that is 1 plus tangent squared of x equals secant squared of x, right? So that Pythagorean has a secant squared and a 1, but I want to make that equation look like that. There you go. So if I were to subtract the 1 over, those are going to cancel. So there's the secant squared of x minus 1, but what should that equal? Tangent squared of x. Okay. See, I know by manipulating that identity, secant squared minus 1 is tangent squared, so I'm going to replace him with tangent squared. Okay. All right. Now, you remember that little, yes, sir? The exit ticket? Turn in, please. Now, you remember we had that one little idea. We can rewrite a fraction. We can take the numerator and just pull it out in front as long as it's still multiplied, right? So I would probably do that. I'm going to pull the tangent squared out in front, and that's times 1 over sine squared, right? Is anybody thinking there's something I can now do to pretty much finish up the problem? There you go. Now, tangent is sine over cosine, so tangent squared is sine squared over cosine squared times the 1 over sine squared. Now, why'd you want me to change it to sine squared over cosine squared? Because those are going to cancel. Now, remember I said it was going to go to one trig function? What's the reciprocal of 1 over cosine? Secant, so 1 over cosine squared would be secant squared. Okay, so that whole expression, the original problem that we started with, is actually equivalent to secant squared. There we go. Okay. So there we go. And that's the thing about these. I mean, sometimes depending on what identity or what algebra skill you use, it's still going to get you where you need to go, but it might be a little longer than if you did another method. It really just depends on how you want to simplify the problem. What do you think works? The best piece of advice I can give on these, don't give up. Okay. If you're running out of ideas or the one idea you had doesn't work, okay, just go back to the beginning, try another idea. Okay, if that identity didn't work, go for it. All right. Okay, questions. All right. I'll tell you what, we'll go ahead and stop there today. We will pick this up again tomorrow. We'll just keep going.